All right, next topic is tree diagrams. Now, tree diagrams are useful in kind of looking at the very details of probability, but they can only be used in certain situations because they get very complicated after 2 or 3 steps. So something like this, where we're tossing a fair coin 3 times. This is a good situation to illustrate a tree diagram. So I have my handy dandy pointer here, and we'll go through this. All right. So a fair coin, meaning after the first toss, the probability of getting heads is 1/2, and the probability of getting tails is 1/2. Right? 2 possibilities after 1 toss. Now, if we move on to the second, where's my, am I doing the wrong end here? There we go. Where are you? There it is. All right. So after the first toss, if that was heads, then after the second toss, we have the possibility of a head on the first toss and a head on the second toss. Probability there, since these are very easily seen as independent events, right? The first toss should have no effect on what the second toss is. We are saying these are independent events. They are in fact independent events if we're tossing a fair coin. So it's 1/2 probability for the first, 1/2 probability on the second toss. We get 1/4 as the probability of getting 2 heads in 2 tosses. First toss can be a head, second toss can be a tail. Again, it's 1/2 times 1/2. These are equal probabilities here. We're talking about equally likely outcomes. Heads is 1/2, tails is 1/2. So that's why all these probabilities here after the second toss are going to be the same. There's 4 possibilities, and each one has a probability of 1/4. Just like here, there was 2 possibilities, and each one had a probability of 1/2. Each time they're going to add to 1 because we got to get a head or a tail. Again, we're ignoring the Twilight Zone episode where it falls on the edge, which again, you should watch. Google it. Twilight Zone episode where the coin falls on its edge. It's worth watching. Anyway, after 2 tosses, there's 4 possibilities, right? Heads, 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 tails, tails, heads, tails, tails, right? Each with a 1/4 possibility. Notice it's 2 squared after the second toss. It's 2 to the first after 1 toss in the number of possibilities. 4 possibilities after 2 tosses. Now we go to a third toss. Well, if the first 2 tosses are heads, then that leads to 2 possibilities for the third. If the first 2 tosses are heads and tails, again, 2 possibilities for the third toss, either heads or tails. And same thing for the other possibilities. If it's tails, heads, heads or tails again. And here we have 2 raised to the third number of possibilities after 3 tosses. So notice here, if the number of possibilities is 2, and the second step, the number of possibilities again is 2, and the third again is 2 possibilities, you multiply the number of possibilities. 2 times 2 times 2 gives you 8 possibilities after 3 tosses. These are the 8 possibilities. Again, if it's a fair coin, they all have a probability of 1/8, and it has to be one of them. So the total probability, as we discussed earlier, of the entire sample space, which is this, has to add to 1. And then we can ask, again, once we have this information about tossing a coin 3 times, a fair coin, we can ask these probability questions and look at the results and easily determine our answers. So here, probability of greater than or equal to 1 head. So either 1 head, 2, or 3, you count them up. That's at least 1. That's at least 1. So that's 2, 3, 4, 5, 6, 7. So 7 out of the 8, you get at least 1 head. And the rest of these, again, just more examples. The probability of exactly one head, that's going to be a lot different. Exactly one head, well, that's only this one, and this one, and this one. So that's 3 out of 8. So hopefully you see what's going on here. More than 2 tails, so that's 3 tails. There's only 1 out of 8 that gives you 3 tails. So 1 out of 8 is the probability. Greater than or equal to 2 tails, so 2 or 3 tails. 1, 2, 3, 4. 4 out of 8, or 1/2 is the probability there. And just a couple more examples. Exactly 2 heads, you can count them up, verify that's correct. Less than 2 tails, you can verify that that's correct. All right, so this is a nice example of a tree diagram. Now, like I said, we can't really take this, if we go to a 4th toss, now we're talking about 16 possibilities, and it gets kind of complicated. So we'll do one more example where the possible outcomes don't have an equal probability, just to show you that. Now, don't be intimidated by this. This is just a tree diagram, and again, this is why we don't take it very far. But it's a good representation of probability at a kind of a minute level. You can really see where the probabilities come from. So let's see if we can bring this a little closer, since these numbers are a little smaller. All right, so here we're talking about 10 marbles in a jar, and we're picking one at a time without replacement, meaning we're picking one, we're setting it to the side, then we're picking a second, setting it to the side, and a third. That's without replacement. And we're saying that we have oh, there it is. 3 red marbles, 6 blue marbles, and 1 white marble. We're going to designate that as R for red, B for blue, W for white. So very similar to what we just did, except now the probabilities are not the same for each outcome. Here, probability after the first choice, the probability of getting a red was 3 out of 10, right? 3 out of 10. So that was the probability of getting a red. 6 marbles out of 10 were blue. 1 marble out of 10 was white. So those are the only 3 possibilities after picking 1 marble from those 10. And again, notice they're going to add to 1, right? Because you got to get either a red, blue, or a white. And similar to what we did before, if the first one was red, we have 3 possibilities for the second. It can either be red, blue, or white. So we can have red and red, red and blue, or red and white after the second choice if the first was red. And in a similar way, if the first was blue, we can either pick blue and then red, blue and then blue, or blue and then white. The probabilities, notice here, without replacement, very important. Probability of getting red and red. Now here, these probabilities are not independent because the second choice depends on what you got for the first choice. Like for instance here, if you got a white marble on the first choice, then you have no probability of getting a white marble on the second choice because there was only 1 white marble, right? There was only 1 white marble. So the probability of getting 2 is 0. So these are not independent events like the heads and tails were once we get to the second level. But we do still multiply the probabilities. The only thing we have to take into account is we've removed 1 red marble at this point. So there's only 9 marbles left, and there's only 2 red ones. So the probability of getting a red marble on the first draw, and then the probability of getting a red marble on the second draw, we have to remember now there's only 2 red left out of 9. So we multiply that together, and we get this number. I converted them all to 30ths because I wanted to show you when we add all 9 of these probabilities, again, we will get to 1 because that's the entire sample space after 2 choices. So in a similar way, we calculate the probability of red on the first, blue on the second. Here's the probability of red on the first. Now there's 6 blue out of 9 left for the second choice. Multiply that together, just putting into 30ths so I can add them up later on. Similarly for red and white, blue and red, blue and blue, so on. All these probabilities here, calculating. Again, notice that was 0. And if you add these together, notice 2 and 6 is 8, plus 1 is 9, plus 6 is 15, plus 10 is 25, 27, 28, and 30. Adds up to 30 over 30 because it has to be one of these 9 possibilities after the second choice. And notice, again, the number of possibilities comes from the possibilities after 1 is 3. And then there's 3 choices for the second. So 3 times 3 gave us these 9 possibilities after the second choice. Now we're just going to kind of leave it there, but I don't, we could find the probabilities for all of these 27 possibilities after the third choice, right? 3 possibilities here times 3 possibilities at the second times 3 possibilities, even though there's only really 2 possibilities. If you get a white marble, some of these anything with more than 1 white is a 0. So this would be a 0, 0, 0. Anything with more than 1 white marble is going to be 0. All these with 2 white marbles is 0 because, again, there's only 1 white. But again, if we look at it, as branches of the tree, 3 times 3 times 3 gives us 27 possibilities after the third choice. Again, even though some of those possibilities equals the probability is 0. So that is tree diagrams. See you next time.